Okay, Assalamu alaikum. So in this session, we'll learn about loops. We have covered two types of loops, and I guess these are the only types of loops that are available in Octave. So one is the for loop, the other is the while loop. The for loop is a purely counter control loop. That means like you have a loop counter and from the values of the loop counter, the loop actually runs a predefined number of times. So you use the for loop when you know that you have to repeat a certain process or you have to repeat a certain number of steps, a certain fixed number of times. When there are situations where you don't know how many times do you need to execute something, then you can go for the while loop. The while loop in that sense is more versatile. So let's get started. So in this session, like we'll create a script file, and in that script file we will use the for loop to do something. And what we'll do is something very trivial, not that complex. So the point is that I want to demonstrate how you can use the for loop to do something iteratively or repeatedly. So if you want to repeat something over and over again, this is how you can do it. So say for example we have a very simple problem, and the problem is that we have a number. Say we store that number in some variable. Let us call that variable as num, and let us assign that number some value, any value. Say for example we have the number, and we assign the number the value 78. Okay, so let us save this script file. It is always a good idea to save the script file. In Pakistan, like you can always lose power at any time. So um regarding saving script files, so there are two things that you need to remember. If your script file contains some function, like if you want to create a function, and we talked about the function as well. A function is a block of code that does something specific. For example, in this window right here, you can see we have this function is prime. So is prime is a function that basically determines whether a number is a prime number or not. So it would return you true if it is prime. It would return false otherwise. So if you need to create a function, then the name of your script file should be exactly the same as the name of your function. Okay, so this is a requirement. If however you're not creating any specific function, so you can name your script file, you can give it any valid name that you can give to any identifier. So a valid name always starts from some letter or one of the allowed special characters, not from a number. So let us say we name it like this. Okay, so I am naming it according to the date. So we have created this script file, and in this script, like in this particular session, what we'll do is we will learn how to use the for loop, and we will learn the for loop by solving a very simple and trivial problem. And the problem is that we have this number. Right now we have assigned it one value, that is 78, and we want to know about the factors of this number, like how many numbers are there that can divide 78. So we want to find out all the factors of 78, and those factors can be proper factors or improper factors, we don't care. So all we need to do is that we want to find the factors of 78. Now how can we find the factor of a number using a computer? So what we can do is we can in Octave we do not have a modulo operator, just like we have in C++ or Java. So in C++ or Java you can use the modulo operator. Usually it's something like this. So if I want to find out the remainder after dividing 45 with say 4, so I can use the modulo operator in C++, C or Java or something like that. So if I say 45 modulo 4, so it will return me 1. So that is the remainder that you'll get when you divide 45 by 4. But in Octave you cannot do that. So if I press enter, I get the same answer. So nothing happens basically. The percent sign is basically used for commenting out something. So whatever comes after the percent, it is treated as a comment. So it is basically ignored by the Octave interpreter. So nothing happens. In Octave, if you want to find the remainder when one number is divided by another, you have to call the built-in function mod. So the built-in function mod, it takes in two arguments. One is the dividend and the other is the divisor. So if I want to know what would be the remainder when 45 is divided by 4, this is how I need to provide numbers to the mod function. So 45 will be divided by 4 and you will not get the quotient, but you will get the remainder. So in this particular case, the remainder is 1. So when the remainder is 0, then we know that, for example, in this case, when 45 is divided by 4, we'll get 0 as the remainder. So when we get 0 as the remainder, then we know that 5 is a factor of 45. Okay. So if you want to do it once, you can just call the mod function, give it the input arguments, and then you will get the result. But here in this particular problem, we want to repeat this process because we want to find out all the factors of 78. Now, how can we find all the factors of 78? So we know that the factors, if you want to know about the factors of a number, so we need to start from, say, 1. So we'll start dividing 78 by 1, then 2, then 3, then 4, then 5. And then we'll go, say, up until 78 itself, up until the number itself. And we will divide the number 78 by all these numbers. And wherever we get the remainder as 0, for that number will be considered as the factor of 78. So like from this discussion that we just had, so it is apparent, it is clear that we need to repeat a certain process, and that process is that we need to divide 78 by some number and we need to look at the remainder. If the remainder is 0, then we'll say that some number with which we divided 78, it is a factor of 78. If that is not the case, we move on to the next number. Okay, so this is what we need to repeat. So if we want to check whether one number, any number, say for example, we have this number, say for example, we have this number divisor. Let us call it divisor. Divisor is equal to 1. So if I want to know whether 1 is a factor of 78, so this is what I need to do. I need to call the mod function. I need to give it 78 and I need to pass on 1. Okay, so the mod function will return me the remainder. So I need to compare the remainder with 0. So if the remainder is equal to 0, so this is how we compare. This is the equality operator. It is the relational operator. It basically tests whether the right hand side and the left hand sides are equal. This is the assignment operator. So newcomers, when they start programming, so they often make mistakes like these. So they confuse the assignment operator with the equality operator. So this is the equality operator and this is the assignment operator. The assignment operator only assigns the right hand side expression, the value of the right hand side expression, to the left hand side. So on the left hand side we usually have some variable to which we assign some value, but this is the equality operator. So we need to check whether this function will return us the remainder when 78 is divided by 1, and we will compare that remainder with 0. If it is equal to 0, again, so you have this decision structure if, which allows you to make some decisions. So now whatever comes after if, that statement will be conditionally executed. So if this condition is true, then the statement that will appear at line number 5, that will be executed. Otherwise it will not be executed. Okay? So if the remainder when we divide 78 by 1 is equal to 0, so then we want to display that 1, okay, display 1, and then we want to display is a factor of, and then we want to display 78. So this is unfortunately how it is. At least this is how I know it is. So we want these statements to be executed only if this condition is true. So we have made the execution of these statements conditional to we have made it conditional. So if this condition is true, only then these statements will be executed. Okay. So then afterwards we don't want to execute anything else. So this is the end of it. So these statements, now their execution is conditional upon this condition. So this we create a condition using relational operators. So here we are using the equality operator. So if this condition is true, if the left and right hand sides are true, then only then these statements will be executed. Okay. So let us execute this code for this particular case, and you'll see that you will get this message 1 is a factor of 78. Now code that uses these constant values, it is fairly useless. Like we do not write code for a specific case, we write code that is more general. Okay, so generality comes with the use of variables. So 78, if we replace it by num, and divisor, if we replace it by divisor, then it would make this code more generic. So here we would say divisor, and here we would say num. So divisor is a factor of num. So if we run this code for these specific values of num and divisor, you won't see any difference in result. Okay, so you will get the same result. So if you run this script file, divisor is equal to 1 is a factor of num is equal to 78. The only difference is that previously it was 1 is a factor of 78. Now you see divisor is equal to 1 is a factor of 78. You see something like this. Okay, so I need to clear this display. In fact, if you need to clear the display each time you run the script file, so you can put this clear command window statement here, so it will clear the display each time we run this code. Now this code is good enough for checking only if we have just two numbers, and we want to know whether one is the factor of another. So what if we want to solve the problem that we initially discussed? What if we want to check what if we want to check if there are like many numbers, and among many numbers we want to find out which numbers are factors of a certain number. So that certain number is stored in 78, and we want to find out if 78 has like more than one divisors, not just one. We are interested in finding out all the divisors that 78 can have. So so if we want to do something like that, we need to repeat this process. Okay, so if you want to repeat something, you can do that using loops. So here I have indented this code. So I have used the tab character to indent it, because now I'm going to create a loop. So I want to repeat this block of code, so I need to enclose it within inside a loop. So a loop is basically a control structure or a repetition structure that almost every programming language provides you with, and using that control structure you can basically instruct the computer to repeat a certain block of code. So that is what we are going to do. So right now we are going to use the for loop. So the for loop, the syntax for the for loop is something like this. You use the keyword for, okay, and so this is where the loop starts from, and how do we specify where does it end? So you basically put the keyword end. So now this for and this end keyword, they mark the beginning and the end of the for loop. Okay, so whatever is in between these two, it will be repeated. Okay, so it will be repeated. That is the idea. How many times would it be repeated? So that depends upon whatever we specify here. Now the basic structure of a loop is like, if you want to use a for loop, the basic syntax is like this. So I will specify the basic syntax in the form of a comment. So you use the keyword for, and then you specify the initial value for your loop counter, Then you can specify the step size, and step size is optional. That's why it appears between uh, these what can I say, triangular brackets. So step size is optional. By default, step size is 1. So basically, it's the same as generating a vector. So what we do here is we generate a vector of values, and that vector of values is basically treated as the loop counter, and then you specify the final value. So this is how the for loop works. So starting from this initial value, the for loop will run for each value in this vector. So until we get to the final value, this loop will basically repeat itself. So this block of code will be executed for each value of the loop counter. And the values of the loop counter, they start from the initial value, they are incremented by the step size, and they reach up until final value, something equal to final value or less than final value, something like that. Okay, so we want to repeat this thing, so we need to specify or we need to specify a loop counter or a vector of values for the loop counter. So we need to specify that. Now we need to use the loop counter inside the loop as well, because if you remember the purpose of writing this code, the purpose of writing this code is that we basically want to find all the factors of a given number. So if the given number is num, so we want to find out all the factors. And in order to find out all the factors, what we need to do is we need to start dividing that number from starting from 1 going up until that number. Okay, so this is right now, this is what we want to do. This is how we want to do it. So if you see, like, divisor is something that we need to change. We want our divisor to start from 1, then 2, 3, 4, 5, 6, and we want it to go up until, say, 78. This is what we want to do. So we can use the divisor as a loop counter. We can say divisor is equal to 1. Okay, so that is the initial value of our divisor. Okay, so here I missed something. So here we have our loop counter, or simply say counter. For counter is equal to initial value to step size and then final value. Okay, I missed the counter, sorry about that. So for, and then you specify the loop counter, assign this initial value, and the loop counter then varies up until the final value, and the difference between each consecutive values is the step size. Okay, so for divisor is equal to 1 and divisor equal to 1, 2, we want the divisor to start from 1. We want the divisor to be incremented by 1. So if you want it to be incremented by 1, so you do not need to specify the step size. Then the step size by default is 1. So whether you write here 1 or you skip it, it doesn't make any difference. So you can explicitly specify the step size if you want the step size to be different than 1. So we want the divisor to start from 1, we want it to be incremented by 1, and we want it to go up until the number itself. We want to go up until the number itself. Okay, so this is how we want the divisor to vary. And for each value of the divisor, we want to divide num and find the remainder, and then we want to compare the remainder with 0, and we want to see whether it is equal to 0 or not. If it is, that means this particular value of the divisor is a factor of num. We want to display that. If it is not, we don't want to do anything. Okay, so this is what we want to basically do. Okay, so let us execute this code. So if you execute this code, here is the output of this code. So we clear the command window, and then we start dividing 78 by 1. So 1 is a factor of 78, 2 is a factor of 78, 3 is a factor of 78. Okay, so 3 2s are 6 and 3 6 are 18, so 326 are 78. 6 is a factor of 78, 13, 26, 39, and 78 itself is a factor of 78. Okay, So this is how you can use the for loop to do something very simple, and that simple task is to find out the factors of a number. So you use loops to repeat a process, and this is a process that we want to repeat. This process can test whether one number is a factor of another number. Okay, so we want to repeat this process. Why? Because we want to test whether we want to find out the factors of a given number among many numbers. Okay, so those many numbers are is this vector which starts from 1 and goes up until num, in this case 78. We can change it. For example, say we can make it say triple one. Triple one would have fewer factors, so we can check that. So one of its factors is 1, and then 3 is a factor, 37 is a factor, and 111 itself is a factor. So 111 is an improper factor. So if you just want to know about the proper factors mean it is a factor of the number and it is less than the number at the same time. So we know that we don't need to go up until that number. We just need to go up until half of that number. Okay. So if we have 100, say, so we know that its highest proper factor is its half, 50. So beyond that, we don't need to check whether it has any factors or not. So this way we will be able to find out all the proper factors of a number. Okay. So if we run this code, so here, like, you don't see 111 as a factor of 111. So you just go up until half of 111. Okay. So this is all about the for loop. I hope you will understand how the for loop works, and you will be able to use it. So in the next sessions, we will complicate this problem a little more, and we'll reuse the for loop, but this is how the for loop basically works. Okay, see you in the next session.